Hello, fifth graders, and welcome to week 4 of remote learning, and this is our math lesson. Today in math, we are going to focus on finding volume. So our question for today's math lesson is, how do you find the volume of a rectangular prism? So our goal by the end of this math lesson is that you will be able to walk away feeling comfortable and confident, saying that you learned how to find the volume of a rectangular prism. As you've come to find out, there is no typical usual visual learning bridge, and instead for remote learning, I will be your visual learning bridge. So as usual, I will walk you through a couple of sample problems, and again, the video will pause every now and then for you to try some out to get the hang of it. So let's get started.
Before we begin solving problems, we need to discuss a very important vocabulary term, and that term is volume. So what is volume? Volume is the amount of space that a solid takes up. In other words, it's the amount of space inside a three-dimensional figure. So here's my example, but I want to explain that a little bit more. So last week, we focused on finding the area. An area was similar because it was finding the amount of space inside of a shape. The difference between area and volume is that area involves finding the amount of space inside a two-dimensional figure, which means it's like a flat shape. So for example, last week we saw problems like this, right? Where you had squares and rectangles, and you had to find the area within this space. But this is a two-dimensional figure. It's flat, there's no depth to it, right? This week's going to be slightly different because we want to find the amount of space inside a three-dimensional figure. So I know this is just a picture on a piece of paper, so it's kind of hard to tell. So here's my sample, right? A 3D object. It's not flat. There's a lot of space inside, right? And we need to figure out how much space is inside a three-dimensional figure. And that is volume. As always with measurement, we need to consider units. Example units are inches, centimeters, yards, and so on. With volume, the units are a little bit unique. Volume is measured in cubic units because it's the number of cubic units you can fit in a shape. So here we have a three-dimensional shape, and you need to figure out how many cubic units it would take to fill this entire shape. So if it's kind of hard to tell, this is a cubic unit, but I want to show you my example that you're probably used to seeing, right? Here is a cubic unit. So you're trying to figure out how many of these it would take to fill an entire shape. So you could look at the shape and you could try to count them one by one to figure out how many cubic units it took. That can get a bit challenging, especially when you can't necessarily see all of the cubic units in a shape. So I know this is a three-dimensional shape, and I can see some of the cubic units, but I can't see all of them. Like for example, with this row, I can see there's a row there, it starts here, but I can't see what's behind it from this view. I know they're there because it's a three-dimensional shape. I just can't see how many are behind it. So counting the cubic units could be challenging, and it will especially be challenging when you want to find the volume of a swimming pool. There's no way you'd want to fill a swimming pool with a bunch of cubic units and then count them one by one to figure out how many it took to fill the swimming pool. So we need a quicker and more convenient way. We are going to discuss the formula for finding the volume of a shape so we do not have to count the cubic units one by one. Let's discuss the formula for finding volume. Depending on the shape, there are different formulas for finding volume. The formula for finding the volume of a rectangular prism is length times width times height. You'll often see it written this way. This is just the abbreviation to show that if you want to find volume, you need to do length times width times height. It is very similar to finding area, right? Last week, we learned that the formula for area was length times width. With volume, there's one extra step because there is still a length to the shape. There is still width, but now there is height. That is what's making it three-dimensional, which adds so much more space inside the shape. So we have one extra step. So to find volume, we'll need to do length times width times height. And I did point out that depending on the shape, the formula could change. We are just going to focus on rectangular prisms today. So some examples of some rectangular prisms are, say, a juice box, right? A juice box is a rectangular prism. It's shaped similar to a rectangle, but it is three-dimensional, so that's what makes it a rectangular prism. Or another example might be a box of crayons. This is another example of a rectangular prism. Another example that you might see often is a box of cereal. And one more final example would be, say, like a birthday gift. So all of these are examples of rectangular prisms, and those are the shapes we're going to focus on today. So to find the volume of a rectangular prism, we will do length times width times height. Now that we have discussed the formula for finding the volume of a rectangle, we're ready to try some practice problems. I will begin by solving a problem for you before you actually try some out yourself. So let's get started. We have a rectangular prism, so we can tell that this is a three-dimensional shape. So to find the volume of this rectangular prism, we need to figure out how many cubic units will fit within this shape. Now with this one, the cubic units aren't drawn out for us, so I couldn't count them even if I wanted to. So I'm going to use my formula, length times width times height. The length of this rectangular prism is 24 feet. The width of it is 10 feet, and the height is 12 feet. So to find the volume, we'll need to do length times width times height, or in other words, 24 times 10 times 12. So we will try that out. So I have my problem set up for me. I'll move this one so we can see a little bit better. 24 times 10 times 12. So to begin, I'm just going to start with two of the numbers to multiply. I don't want to start with all three. That would be a bit challenging. So let's start with these two. 24 times 10. Now with this problem, so we'll just ignore this for now, I notice right away that I can cover up the 0 in the 10 and just see it as 24 times 1. Well, 24 times 1 is 24, and then I can just add the 0 back in to get 240. So 24 times 10 is 240. But I'm not done yet because I was ignoring that times 12. So I'm going to pull that times 12 down now. So then my final problem will be 240 times 12. Well, that's large multiplication that I can't necessarily do in my head. So I am going to stack it to make sure I don't make any errors. So 240 times 12. Okay, here we go. I'll cover up the tens place for now. 2 times 0 is 0. 2 times 4 is 8. And 2 times 2 is 4. Okay, moving on to the tens place. So ding, add that 0. And here we go. 1 times 0 is 0. 1 times 4 is 4. And 1 times 2 is 2. We'll add our partial products. So we get 0 plus 0 is 0. 8 plus 0 is 8. 4 plus 4 is 8. And nothing plus 2 is 2. So we get 2,880. Now, to properly write this, we have a few options. So with the problem, I know the unit was feet. But when it comes to volume, I know that it needs to be written as cubic feet. So there are a handful of ways I could write this. Here are our choices. I could write it out word for word and write 2,880 cubic feet. I could abbreviate it slightly and do 2,880 cubic feet and abbreviate the word feet. Or another option that would probably be the quickest option would be to write it like this. It's still read as 2,880 cubic feet. Again, remember when we did our exponent unit, we learned that when there's a 3 up there as an exponent, it can be read as cubed, right? So 2,880 cubic feet. So I will leave it up to you today and how you want to write your answer. But I think today I'm going to write it the quickest way I can with as much abbreviations as possible. So the volume then for this rectangular prism, and I can write that right in here. So I'll put V for volume is 2,880, and I'm going to abbreviate mine, cubic feet as our final answer. Now that you've watched me solve a problem, it's your turn. So here is your rectangular prism. It has a length, a width, and a height. So its length is 9 inches, its width is 8 inches, and its height is 5 inches. So you will need those dimensions to find the area of this rectangular prism. So go ahead, try it out, and then we will check your work. Let's check your work. So to find the volume of this rectangular prism, you needed to use the formula length times width times height, or in other words, 9 times 8 times 5. So I rewrote my problem on a separate piece of paper to give myself some more room. So to begin, I'm going to multiply the length and the width, which was 9 times 8. 9 times 8 is 72. I'm not quite done because I was ignoring that times 5, so I'll just pull that down. So now we have the problem 72 times 5. To make sure I'm being accurate about this, I'm going to stack that problem because it is a large multiplication problem. So now we have 72 times 5. So here we go. 5 times 2 is 10, so write the 0, regroup the 1. 5 times 7 is 35, add 1 more, that makes 36. So now we know that 72 times 5 is 360 as our final answer. So to properly write the volume of this rectangular prism, we'll go ahead and write V for volume. And we know the answer was 360, but I want to give it the correct units. It was inches, but I know with volume, it's cubic inches. So I'm going to abbreviate mine, inches, and then I'll add the little 3 above to show that it is 360 cubic inches. All right, let's try some more problems so that we get really good at this. This time, it's going to be more of like a story problem format. And this story problem is actually very similar to something I just did the other night when I was trying to figure out the amount of chemicals my pond would need. So this is a very realistic story problem. So here we go. I have a rectangular prism-shaped pond. I need to add a chemical treatment to it to kill off the algae. The packaging says I need to figure out the volume of the pond to determine how much chemicals I will need. What is the volume of my pond? So here we have my pond. It is a 3-dimensional shape, and I need to figure out the volume, the amount of space inside. So the length of this pond is 5 feet. The width of this pond is 3 feet, and the height of the pond is 4 feet. So to find the volume of the pond, I'm going to use my formula, length times width times height. 5 times 3 times 4. So again, I rewrote this on a separate piece of paper to give myself some more room. So to begin, I'm going to start by multiplying the length and the width. So 5 times 3. 5 times 3 is 15. And again, I know I'm not quite done because I was ignoring that times 4, so I'll pull that down. So the next problem is 15 times 4. Kind of a large multiplication problem, so I'm going to stack it just to make sure I'm being accurate. So now we have 15 times 4. So here we go. 4 times 5 is 20, so you write the 0, regroup the 2. 4 times 1 is 4, plus 2 more is 6. So we end up with 60. So if I go back to my pond here, I now know the volume is 60, so I can write V for volume. And it was 60, but I want to give it the correct units. This one was in feet, and remember, volume is measured in cubic feet. And I'm going to abbreviate feet, add my little 3 up there to show that it is cubic feet. So the final answer is that the volume of this pond is 60 cubic feet. All right, now that you've watched me solve a story problem involving volume, it's your turn. And again, this story problem is actually very realistic. Mrs. Freeman was just talking to me about how she wants to add a sandbox to the school playground. So again, another realistic story problem. So here we go. Mrs. Freeman wants to have a new sandbox built on the school playground. She wants to order the correct amount of sand to fill the sandbox. What is the volume of the sandbox, right? She wants to fill that amount of space, so she's going to need to find the volume. So for this sandbox, the length of it is going to be 24 feet. The width of it is also going to be 24 feet. But the height, how tall it is going to be 2 feet. So the length is 24 feet, the width is 24 feet, the height is 2 feet. So find the volume of that sandbox. Let's see how you did. So again, the length was 24, the width was 24, and the height was 2. So to find the volume, we need to do length times width times height. So I rewrote my problem on a separate piece of paper to give myself some more room. So we've got length times width times height. So to begin, I'm going to do length times width, which was 24 times 24. Now that's a large multiplication problem, so right from the get-go, I am going to stack that problem. 24 times 24. All right, I'm going to cover up the tens place, and here we go. 4 times 4 is 16, so you write the 6, regroup the 1. 4 times 2 is 8, plus 1 more is 9. Cross off that 1 so you don't use it again, and then moving on to the tens place. So ding, add the 0. 2 times 4 is 8, and 2 times 2 is 4. Then we'll add our partial products. 6 plus 0 is 6. 9 plus 8 is 17, so we write the 7, regroup the 1, and then 1 plus 4 is 5. So we end up with 576. But I know I'm not quite done yet because I was ignoring that times 2. So now my new problem is going to be 576 times 2. Again, that's a large problem, so I'm going to stack it right from the get-go. So 576 times 2. Here we go. 2 times 6 is 12. Write the 2, regroup the 1. 2 times 7 is 14. Plus 1 more would be 15. Write the 5, regroup the 1. 2 times 5 is 10. Plus 1 more would be 11. So we end up with a final answer of 1,152. So if I go back to the sandbox here, now I know that the volume for this sandbox is 1,152, and I want to properly label it. It was feet, and volume is measured in cubic feet. So the volume of this sandbox is 1,152 cubic feet. All right, I'm sure you're probably getting the hang of this, but we're going to do just a couple more to really get this down. So far, all of your problems that you've seen have given you an image, which made it nice because you could actually see the length, the width, and the height. But sometimes you don't have an image to look at. You just have the numbers. So we're going to try one without an image being provided. So here is the problem. Sam has accumulated quite a bit of outdoor items. She decides she needs a shed to store these items. She realizes her shed needs 480 cubic feet of storage. She decides to shop online and finds a shed that is 6 feet long by 5 feet wide by 8 feet high. Will the shed be big enough to hold all of her items? So again, no visual, but we have all the information we need to solve this. The shed she's looking at is 6 feet long, 5 feet wide, and 8 feet tall. She needs the shed to be 480 cubic feet. So notice right away it says cubic feet. So we need to find the volume of this shed that she's looking at to see if it will be big enough to hold all of her items. So we're going to do length times width times height. So I did put that on a separate piece of paper. So we have the length times width times height. So I'll start with the length and the width. So the length was 6, the width was 5. So 6 times 5 is 30. Again, I'm not quite done because I have been ignoring that times 8. So the next problem, I'll pull that down, would be 30 times 8. Kind of a larger problem. I can stack it to make sure I'm being accurate here. So 30 times 8. Here we go. 8 times 0 is 0. And then 8 times 3 is 24. So we end up with 240. So if I go back to my story problem here, I know now that the shed that she was looking at was 240. If I give it the proper label, it was feet. It'd be cubic feet for volume. And I know that earlier it said that she needs the shed to be 480 cubic feet to hold all of her things. Well, this shed that she was looking at was 240 cubic feet. So is this shed big enough? And the answer is no. It's only at 240 cubic feet. She needs it to be 480. So the answer to that would be no, that shed is not big enough, so she needs to keep looking for a much bigger shed. Now that you've watched me solve a problem without an actual image, it's your turn. So here is your problem. Your family is moving into a new house. You have helped box up all of the items in your house. The boxes are ready to be loaded into a moving truck. Your family needs a truck that is at least 850 cubic feet. Your family finds a rental truck that is 17 feet long by 7 feet wide by 7 feet tall. Will the truck be big enough to hold all of your family's belongings? So the truck needs to be 850 cubic feet in order to fit all of the boxes. The truck your family finds is 17 feet long, 7 feet wide, and 7 feet tall, which that's the height, how tall it is. So you will need to see if that will be big enough to hold all of your family's boxes. So go ahead and try that out. All right, so let's check your work. So to find the volume of this truck, we will need to do length times width times height. 17 times 7 times 7. So here we go. I will start with the length and the width. So 17 times 7. So that is a larger multiplication problem, so I'm going to stack it. 17 times 7. So here we go. 7 times 7 is 49. So we write the 9, regroup the 4. 7 times 1 is 7, plus 4 more is 11. So we end up with 119. I'm not quite done because I still was ignoring that times 7. So I need to do 119 times 7. Now that's a big multiplication problem, so I'm going to stack it again. So 119 times 7. Here we go. 7 times 9 is 63. So we write the 3, regroup the 6. 7 times 1 is 7, plus 6 more would be 13. So we write the 3, regroup the 1. 7 times 1 is 7, plus 1 more is 8. So we end up with 833. So if we go back to our story problem here, we now know that this rental truck that the family was looking at was 833, and it was feet, so it's going to be cubic feet. And if we go back to the story problem, we know that it said that the truck needs to be at least 850 cubic feet, at least 850. Well, this truck is 833 cubic feet. So is it big enough to fit all of the belongings? And the answer would be no. It was so close, right? It was almost to 850, not quite though. So it wouldn't be big enough yet to hold all of the belongings. So they'd need to find a rental truck that was just slightly bigger. To end our video, I have one final question for you. What is volume? So tell me in your own words what volume is.
All right, fifth graders, that is it for our week 4 remote learning math lesson on how to find the volume of a rectangular prism. Your next step is to go into Seesaw and complete the activity in Seesaw. And I think it's kind of a fun one. It's fitting for the warm weather coming. It involves you creating your own water park with different pools, and you get to get creative with it. So I can't wait to see what you come up with. Even though it's fun and involves some creativity, please be careful, slow down, show all of your work so that you can be accurate, and have fun.